Alright, this is a video lesson for Unit 1, Lesson 4, which is every statistician's favorite article of clothing, socks. SOCS is an acronym, SOCS, that stands for shape, outliers, center, and spread. And we're going to use these four measurements or qualities to compare two data sets. So, some details on shape, because we haven't talked too much about this. Okay, first, we have three main types of shapes. We have symmetric, which you see starts low, peaks high, ends low. We have skewed to the left, which means that we see the peak off to the right, but the tail is off to the left. Okay, so when we talk about the direction of the skew, we're talking about where the tail is. Okay, for both of these. Over here, skewed right because the tail is off to the right. We're also talking about the same thing for whiskers in a box and whisker plot. When you have a long tail to the right, you're skewed right. When you have a long tail to the left, you're skewed left. So we're going to take a look at a stem plot over here, and we're going to decide if this is skewed left or right or symmetric. Now, the nice thing with stem plots that not everybody realizes is if you look at it sideways, which I'm going to do by rotating the picture, if you look at it sideways, you actually see a histogram. Okay, I see that this starts low, peaks in the middle, and ends low, which we would call symmetric. And you can just do that by turning your head. Okay, so I would call this shape symmetric. Couple more examples. This first one, I see a peak off to the left and a little bit of a tail here off to the right, so I would call this skewed right. On this one, I see a peak pretty centered, and I don't see necessarily a tail. You might want to argue that this is a tail because it's a little bit lower, but it's no longer than what's going on over here, so I would call this roughly symmetric. It's definitely not perfectly symmetric, but the peak's in the middle, so I'm going to call it symmetric. So now we're going to get into an actual problem of socks, now that we have kind of an idea of shape, and we already kind of know how to do outlier, center, and spread. Okay, so as far as shape is concerned, the easiest way to get this, if we're given a 5-number summary, which is what we're giving here, if you don't realize, this is not a data set. This is actually a 5-number summary that they're giving us. So this is our least val, greatest val, Q1, Q3, and median. Okay, so using that information, we're going to be able to construct a box plot. And we're going to use that box plot to make a determination of shape. So I'm going to start by roughly sketching an x-axis. I'm going to separate this from 0 to 800 since I get kind of low with 175 and I get as high as 760. So here's 0, here's 800, halfway in between roughly is, I could probably do a little bit better than that, halfway in between here is 400, halfway between 0 and 400 is 200, halfway between 400 and 800 is 600. I could keep going if I wanted to. There's 100, there's 300, there's 500, there's 700. That should be plenty to make our box plots. So I'm going to highlight this red to represent sample A. And we're going to start plotting these points. 250 would be between 200 and 300. Okay, so up here. 250, I'm going to plot right here. 320, I'm going to plot just a little bit past 300. 375, I'm going to plot a little bit before 400. 425, I'm going to plot a little bit past 400. And 600 directly above 600. Start connecting the dots here. And there's my box plot. Now we're going to do the same thing with sample B. Sample B, 175 is the first value, a little bit before 200. 300 comes next, then 495, so just before 500. And 650 between 6 and 700. And then 760 between 700 and 800. I'll connect the dots here. And here's this box plot. Okay? Now, we're going to start comparing. As far as shape is concerned, for sample A, I'm noticing that this whisker is longer than this whisker. And that's going to tell me that this is skewed right. As far as sample B, this looks pretty evenly proportioned. So I'm going to say that this is symmetric. And that covers the shape. That's all we need to say about shape. We just described both, and that's a comparison. Okay? Now we're going to move into outliers. In order to do outliers, I'm going to kind of get this out of the way. In order to do outliers, we're going to have to use our outlier range that we learned in that lesson. So the outlier range was found by doing Q1 minus 1.5 IQR through Q3 plus 1.5 IQR. Well, we have that information from the 5-number summary, so we can do this. First of all, our IQR is going to equal Q3, which is 425, minus Q1, which is 320, which gives us 105 as the IQR. So I'm going to plug that stuff in. Okay, I'm going to get Q1, which was 320, minus 1.5 times 105, the IQR, through Q3, which is 425, plus 1.5 times 105. And I'm going to take that to my calculator. I'm getting 162.5. And then on the other one, I'm getting $582.5. Now, using that range, what I can tell for sample A is that the greatest value, 600, is bigger than 582. So I have at least one outlier. So sample A has an outlier of 600. It might have multiple, considering all we have here information-wise is the greatest value, but it has at least one outlier. It has an outlier of 600. And we could tell that because 600 does not fit into that article. Now we're going to do the exact same thing. But we're going to do it for sample B. So I'm going to go through. I'm going to have to find IQR for that. Okay. I'm running out of room, so I'm going to do that over here. IQR equals 650 minus 300. So 350 is going to be our IQR. Our Q1 is 300, so I'm going to have 300 minus 1.5 times 350 through my Q3 is 650 plus 1.5 times 350. And we'll take to the calculator again. $300 minus 1.5 times 350 gives us negative 225. And 650 plus 1.5 times 350 gives us 1,175. Now, all of my 5-number summary numbers, they all fit in that range. So sample B has no outliers. Now, the next measurement is center. And the center is pretty easy to do. Just find the median of both numbers on the box plot. Here's my median over here. Here's my median over here. If one of the medians is bigger than the other, that's all you have to state. Sample A's median is larger than sample B's median because it's further to the right. Sample A's center is larger. It's larger than sample B's. Sample B, oh, no, sorry, I have that backwards. Sample B's center, that's the green one, is larger because it's further to the right than sample A's. Finally, we do spread, which is also really easy. Who's wider? Well, green is definitely wider than red here. It has a greater range, and range is usually what we do if all we're given is a box plot. So we're going to say sample B has a greater range. And we've described using SOCS. All 4 qualities have been addressed. Problem over. And that's kind of as hard as it's going to get, is that problem right there. So let's do a couple more examples. For this one, we're going to start with shape. Okay. Set A, I would say this is a little bit longer than this tail, but not long enough to call this skewed. And I would say the same thing for B. These whiskers are pretty comparable in size. Okay, so I would say both are symmetric. Now we move on to outliers. And unfortunately, that's always going to take us a little bit more time because we're going to have to do the calculation. So for A, the IQR is going to be Q3, which we're going to ballpark this at about 38. Q1, which we're going to ballpark at about, I think we'd call that 21. So 38 minus 21, which is going to be 17. So when we do the range of outliers, we're going to take Q1, which is 21, minus 1.5 times 17, through Q3, which we said was 38, plus 1.5 times 17. It's rough because we're just using the picture, but we're going to use that rough estimate to see if there's any outliers. So I'm typing this into my calculator. I get negative 4.5 through positive 63.5. And I'm going to check. My largest number here seems to be at about 47 or so, and that fits within the range. And this number over here, maybe it's 11. Regardless, it's bigger than -4. So there's no outliers for set A. Let's check set B. Maybe we'll call this 37. And this one 22. So our IQR is 15. So we're going to go 22 minus 1.5 times 15 through 37 plus 1.5 times 15. What are we going to get? We get -0.5 through positive 59.5. Now, both of these numbers, maybe 13, 43 something, they're both inside that range. So there are no outliers for either set. So now we've talked about outliers. Now we talk about center. As far as the center is concerned, this center is just a little bit bigger than this center. So I'm going to say that. Set A has a slightly larger center. I'm going to be specific. It's not much bigger, but it's slightly larger. Okay? And then finally, spread. You can see that from the min to the max over here is a little bit bigger than the min to the max over here. So I would say set A has a larger spread / range. And that's it. Another problem done using SOCS. Okay? Let's do a couple more. If you're feeling really good about this, you probably want to just try these on your own at this point and then just check my answers to see if you're getting it right. But I'm going to keep explaining the same way. So, again, we're going to go shape. For this one, it's debatable again whether or not this first one is skewed. I would probably, let's see here. This is 20 units wide. This is from 60 to 90. This is 30 units wide. That is a pretty decent difference in the length of the whisker. And the other thing I'll point out is you notice how this box is smaller than this box. That leads me to kind of want to call this one skewed right. And then same thing over here. You notice how much bigger this box is than this little box. And then again, the whisker is a little bit bigger over here than over here. I think I would call both of these skewed right. Now, outliers. This is always the long one. We're going to go off to the side and we're going to do our IQR. So for set A, our IQR is going to be roughly 60 and 30, these two numbers. So 60 minus 30 equals 30. So we're going to go Q1 30 minus 1.5 times 30 through 60 plus 1.5 times 30. My calculator says negative 15 through 105. Now, if you look at your data set, you're not going to see anything below 10, so definitely not down to negative 15, and we don't see anything above 90. So this would be no outliers again. Then I'm going to go after B. My IQR here. Let's see what we're dealing with. We've got 72 and 29. 72 minus 29 is 43. That's our IQR. So we're going to have, I'm going to get rid of this line, it's a little bit in the way. We're going to have 29 minus 1.5 times 43 through 72 plus 1.5 times 43. That's negative 35.5 through 136.5. Again, I don't see anything in the data set that would imply any outliers. So neither set has an outlier. Now we're going to move on to our center. And as far as the center is concerned, set A's center is definitely bigger than set B's. So set A's center is larger. And finally, our spread. They have the exact same spread. They start in the same place and they end in the same place. Both sets have the same spread. And that's it. If you're feeling really good about this, you might not need to do this last example, but I'm going to put this in here so you have another example to go off of. And we're going to do one more. So, shape on these. Is going to be, I would call this first one, or sorry, this top one, the whisker's longer and this box is longer. I'm going to call this skewed right. Set 1 is skewed right. And on the bottom, this whisker's longer and this box is wider. I'm going to call this one skewed left. The dreaded outlier question for set 1. Let's see what we got here. I would say that this is at about 30. This is at about 45. This is at about 35. And this is at 50. Okay, so for set 1, IQR is going to be 45 minus 30, so 15. So our range is going to be 30 minus 1.5 times 15 through 45 plus 1.5 times 15. That's going to give us 7.5 through 67.5. Any outliers from that? No, doesn't look like it. Okay. All the numbers from the least value to the greatest value fit in there. So set 1's not going to have any outliers. Then we go to set 2. Also has an IQR of 15. Then we're going to have 35 minus 1.5 times 15 through 50 plus 1.5 times 15. That is going to be 12.5 through 72.5. And again, that means no outliers. Okay, so outliers, no outliers for either. Okay, now we move on to center. The center for data set 2 is definitely bigger. So we're going to say set 2 has larger center. And then finally spread, they have identical spreads again. Both sets have the same spread. So there was a lot of notes here, but it's really the same process over and over again. We're just playing around with SOCS. The hardest part of every problem was just the tediousness of finding the IQR and setting up that range to determine if things are outliers. That's the end of this lesson and the last